Alright, in this lesson we're going to examine some properties of polynomial functions. You will need your graphing calculator for this lesson. I highly suggest you follow along with all my moves on the calculator as you watch the video. So if you need to, pause the video now and go find your calculator. And when you got it, go ahead and read the problem we're given here. And it will become pretty clear what we're studying here right away. So we have this function that represents a stock. And when you're talking about stocks or like Bitcoin or like whatever you would be buying and selling, whatever assets you're buying and selling, what you really want, right, is to sell the stock when the price is highest. So that's our goal here, is to sell when the price is highest. In other words, we want a maximum value of f, our function. And the way we're going to do this is we're going to examine the graph of f on our calculator. Notice that f is like kind of an ugly function. Real life is often ugly, right? But we can use our calculator to see what the graph looks like. So on my calculator, I'm going to adjust my window settings so that I can see the function well in advance. So I'm going to hit the window button and then just change the settings to the way that it looks that I've given you. And this tells your calculator where to look for the function. So it's like the smallest y value it will graph is 0, the biggest is 50. Same with the axes are going to go from 0 to 20. When you look at the graph, you should get something like this. And then what I want you to do is just go ahead and type in your function f exactly as it shows up. Type it in carefully. And when you hit graph, your calculator should draw something like this. So this nice little wavy function. That's why we're studying polynomials, is because it allows us to model things that have different rates of change over time. Okay, now we're going to sketch a graph of this guy, and I zoomed way in because I want you to draw this graph in a certain type of way. So it started basically by the 0, right, in our view, and we're going to kind of exaggerate that first little bump, right? And then it comes up, and then it comes back down. And it doesn't really matter that I kind of messed up the last part, because we're really interested in these maximum values of f right now. So draw your graph something like that. Make sure you exaggerate those maximums so we can see what we're doing. But just draw a sketch other than that. It's okay if it's a little messy. Yours is probably going to look better than mine. From there, once we have that drawn, we're going to use a feature of the calculator to find the maximum for us. So we're going to hit second calc maximum. So let me show you what that's going to look like. I'm going to do second calc maximum as number 4. Notice we also have this minimum button. And it looks a lot like the 0 screen we've seen before. So I'm going to do left bound and then right bound and hit enter. And it's going to be like guess. I'm going to hit enter one more time. And it spits out 14.816. Right? So that's going to be x equals 14.81 is our maximum. So to answer our question, we just answered our question. The answer to our question was on day 14 you should sell. That's when you're going to get the highest value for your stock. And that on our graph is here, right, is day 14. And I also want you to annotate now our left bound and our right bound, because this is tricky to remember. Left bound was here, right bound is here. The reason this is important is because there's another maximum here, and your calculator needs to know which one to look at. So that's why you have to pick kind of left bound, right bound there. Okay, now we're asked to find also increasing and decreasing intervals for our price. Increasing and decreasing. So decreasing, we already know 1 based on how the graph looked. So if I looked at my graph in my calculator, my graph decreases forever, it seems to be, after that 14.86. So we have 1 decreasing interval. I'm going to write it as this, 14.816 to infinity. And I'm going to use interval notation with brackets on 14, parentheses on infinity. But notice there's another decreasing interval. So my other decreasing interval goes from my maximum to my minimum, wherever that is. So I need to find that, right? I need to find that minimum. So I'll do second calc minimum, and you can do this along with me as well. And then left bound, right bound, I'm going to highlight that point. And it's going to be kind of hard to see what I'm doing because that left bound is in the way I set up my window. So left bound, I just point to the left of where I know that minimum is, and right bound, I'm going to go over here somewhere and hit guess. And then it finds that point. And notice here, I'm going to round to 5 as my minimum. So I'm just going to make a note here, minimum equals 5. And so my decreasing interval is going to be from that other maximum to that minimum. And like it turns out now I have to find that again, right? So here I'm going to do second calc maximum and do the same thing. My left bound, I have to work behind the text here. I know my left bound is by the origin probably. My right bound, I just have to be to the right of my other maximum. So it finds the right spot for me. And this, it spits out 2.768 if I round that. 2.7. Notice these are all x values. And for my decreasing interval, it's going to be from my max to my min, right? So 2.768 to 5. And I can use that U symbol in between if I want. So these are my decreasing intervals. I'm going to highlight those here. Decreasing, right? My increasing intervals are going to be the opposite. So I'm going to say from negative infinity, even though that doesn't make sense, we're talking about days here, but just for the sake of illustration, from negative infinity to my first maximum, and then from my minimum, which was 5, to my maximum 14 point. Ooh, and I put an 8 here earlier. Make sure you fix that. That was a little kind of typo. Okay, so all in all, the key takeaway here is 2 things: how to use the maximums and minimums on your calculator. Decreasing and increasing intervals are related to the maximums and minimums, right? And this is how we write them down. On the next page, we're going to try a quick delta math problem before we move on, because they can get not hard, but a little bit tricky. Okay, here we're going to start with some easier ones and move on to some trickier ones. So increasing intervals would be everywhere where the slope is positive. So we have, I believe, 2 increasing intervals in this particular graph. The first is, notice we're always write down x values, -5 to -1, here to here, right? And then also from 1 to 6 are my increasing intervals. My decreasing are, in this case, everything else, right? Decreasing, decreasing, and decreasing. So there are 3 in this case, and then I'm going to use infinity to represent that goes on forever to -5. And then from -1 to 1 is that middle piece here. And then from 6 to infinity is that end piece. Okay. Positive now does not mean the same thing as increasing. And this is important because it's easy to mix these up. So positive means that f of x is greater than 0, meaning y is bigger than 0 is really what this means, right? So positive is anywhere where the graph is above the x-axis. So there's 2 intervals here. So the first interval is from -infinity to -8. And here, -8 gets a parentheses. Think about why that might be. My next one is from -4 to 0. And those both get parentheses. And the reason is that f of x is equal to 0 at those points. So we do not want to include those points, right? Because those points are not positive, those points are 0. Now, we have the exact opposite case here for f of x greater than or equal to 0. That would be the same intervals, but with brackets, right? Because we want to include those 0 points instead of or equal to. So this is not hard, but it can be tricky. So make sure you come back to these notes if you get stuck on this particular part of your practice.